Right, we are now live with Professor Cedric Villani. Is that the way you pronounce it in French?
Very good. Villani, yes.
Villani, not bad, not bad.
Yeah.
I want to thank you very much for taking the time to join us. And I've got many questions that I'd like to ask you. And because I'm a big fan of mathematics, and I know that you are as well, maybe you go into a little bit more depth than I do. There are obviously a lot of questions with regards to popularization of mathematics and that type of thing. And because you're also very involved with physics, it means that you are also a fan of science and technology. So I'm hoping that we're going to try and get all of these things together, if possible, and inspire teachers and students around the world to fall in love with maths again. Because I think the biggest problem at the moment is that when you even mention the word math to any child, a lot of them frown, and a lot of them, oh, I don't like that subject, and some of them see it as a punishment, but you certainly don't. And you are the kind of ambassador that we would like to speak to. So before we begin with anything, I would like to obviously thank you and welcome you and tell you how much I appreciate that you are giving us
My pleasure.
time. Today is a very special day for 3 reasons. One, it is your birthday.
That's right.
So happy birthday. And of course, it is also Sebastian's birthday. So happy birthday, Sebastian. 2, Sebastian is also 21 years old. It's quite a coincidence that both of you are the same age. And then today is World Teachers Day. So in commemoration of World Teachers Day, we would like to give a shout out to all the teachers that are watching and listening today. And then, of course, today is a very interesting day because they are announcing the Nobel Prize winners. And sadly, there's one particular prize that was missing from the Nobel stable, and that was mathematics. So we're going to be talking about that because maybe you're going to give us a little introduction also to the Fields Medal and what it really means. But let's first start at the beginning. You started off at school. Were you a big fan of mathematics at a young age? Or did it grow on you?
I think so. I was quite a nerdy child, and I don't remember. I cannot remember a time where I did not like mathematics. From the oldest of my memories, it always was kind of attractive to me, because
and you have good teachers.
I had some good teachers, but the teachers are good. Teachers are mandatory, but they are not sufficient. You need also to have some interest coming from within. The real teachers who marked me were those which I had when I was, let's see, maybe 12, 13 years old, 13, 14, between 12 and 14 years old. It was the time when I learned to make a mathematical proof. It's a very important age in the development of a mathematician, and I had quite good teachers at the time who did not follow the official instructions.
Is that a good thing or a bad thing?
It can be good, it can be bad. In their case, it was good. At least.
But now, did you show a special skill? I mean, you obviously liked maths, but were you very talented compared to the other kids? Were you some sort of prodigy that people thought, oh, I mean, that kid knows everything like a Gauss, you know, or were you just an above average student that happened to like maths and it went from there?
It was somewhere in between. I was my profile was that of the guy who always has maximal grades in math and is always head of the class, but it was not a prodigy either.
Okay.
Yes, I was very, hardworking and motivated student, and quite interested in many subjects. I ended my my cycle of high school with the best grade in the academy, which is
Wow. So you had a talent. It wasn't just a little bit of luck. I mean, you put in a lot of hard work and you earned your place at the top there.
I guess so. I guess so.
Okay, to be fair. So now the thing is, you're obviously working very hard and you're studying general mathematics at school and learning about proofs. You then go on to university, and that's when you start to focus and specialize. And to get in, and I know that in France, from what I've been told, you've got very prestigious math schools and academies, and then your university that you choose is very important. And you chose a significant university to go to, or did they choose you?
Um, a bit combination. Actually, yes, the French system is quite complicated. Uh, French and the English system are both among the most complicated in the world when it comes to higher education. And in the French system, you have these, in parallel, these very grandes écoles, these famous prestigious schools on the one hand, and the classical universities on the other hand. If you enter a grande école, you will follow, in some cases, as was my case, courses given by professors from the universities, but you will be in the environment of that grande école. And so I entered the École Normale Supérieure. That was, I was age something like 19 years old. And it is arguably the most difficult, in math, it's arguably the most difficult competition in Europe. And in all of Europe, it is the single school which can claim the highest number of field medalists. So it was extremely competitive with a selection of 40 mathematicians per year. But it was not only mathematicians. We also select people in literature, geography, history, physics, chemistry, geology, everything kind of. In total, 200 students per year.
So that's quite a small group of elite
Small group.
students.
Yes, it was really tricky. The only other school which is competing in terms of prestige in France is the École Polytechnique, but it's much easier to enter École Polytechnique in science than École Normale Supérieure. Anyway, it is completely true that when I entered this École Normale Supérieure, I was in general mathematics. Actually, I had more interest in algebra than in analysis. And in the course of a bit more than 1 year, I was completely turned around, and I became an analyst at heart. And nowadays, algebra is the field of mathematics which I understand the least. So it was a complete change. And I worked quite hard at the beginning of École Normale Supérieure, and then I made my personal uprising, let's say. So I stopped attending all the courses and instead spent countless hours going to the movie theater and to the concert and discussing with the students in literature and music and so on. And in second year, I started to work again. And in third year, I had myself elected president of the Students' Union, and this became my full-time occupation. And at the end of third year, I started my PhD, and serious things started. And this was the start of my love story with the Boltzmann equation, and more generally, kinetic theory of gases.
Okay, now this Boltzmann equation is obviously, it's been written about, it's quite well documented in the science world. Can you give us the layman's terms, the general public? What is Boltzmann's, what is it all about, and why would you spend so much time focusing on it?
Boltzmann equation is a way to predict the evolution of the statistical distribution of particles in a gas. And you know, gas is made of many, many particles which have kind of random velocities, but you may predict how this will evolve in time. In the same way as when you have a population of humans and you know the basic demographic parameters such as the birth rate, death rate, etc., migration rate, you are able to predict the shape of the population in the future. The Boltzmann is like this. If you know how the particles are distributed, fast particles, slow particles, particles going this way, that way, this way, how many percent, and so on, you can predict how it will evolve through the action of the collisions between particles. This is the Boltzmann equation.
Now that's quite complicated because environments can change outcomes quite easily.
Even if you don't take this into account, it's very complicated. Even the most basic, if you put it in the box, it will be it's very complicated. And the Boltzmann gained its biggest fame by proving that this equation has a very special property, which is an arrow of time. In this equation, there is a past and a future. There is a notion of disorder, which is called the entropy, which is always increasing, and this distinguishes past of low disorder and future of high disorder. And this was revolution. When you do physics in school, you learn about Galileo, you learn about Newton, you learn about Einstein, but there is nothing in all this which distinguishes past from future. There is no notion of arrow of time. There are some limitations in the theory of Einstein that you cannot travel too fast, but you can a priori travel in both directions in information. There are some limitations. There are also in the equations of Galileo, of Newton, and all of them don't distinguish between past and future. It was with the introduction of statistics that Boltzmann could be the first possible explanation of the arrow of time. So that's why it is so famous also.
Wow. So, I mean, if you take what you've been focusing on, and because it's now esoteric to you, I mean, you've been involved with it for how many years?
It's difficult to count. But I worked on the equation at 10 years. And Boltzmann equation keeps thousands of people busy around the world.
Ah, okay. So, I mean, if it's something that you've been focusing on, and obviously it's something that's close to your heart, and you obviously know a lot about it, the rest of the world, so what? So what? So that you can predict the behavior of particles. How's that going to benefit me as a average person?
Next time you get on the plane, I think that probably some computations have been made by computer to check the shape of the wing of the plane, and for this people routinely use the Boltzmann equation as a way to simulate the atmosphere around the wing. And it's like for everything.
I like the practical example. That's actually very intuitive. I didn't, a lot of people probably don't.
Our world, my friend, you may not realize it, my friend, but we live in mathematics. We are surrounded by the results of mathematical technology everywhere. And be it on Google search or on computations for the population dynamics, or when you are making any big device, it's full of partial differential equations and more generally predictive equations of mathematics and mathematical physics.
But now the equation itself is not, there's no, am I correct in saying you're not proving that it is correct? It is merely an equation that describes the behavior, but that equation could be refined further over time.
Some people work on these. People working in modeling or in the limit from the microscopic dynamics to the macroscopic dynamics. It's a field that keeps many people busy, probably hundreds of people around the world. But people like me are more of the kind who get the equation and fight with the equation, not questioning it, accepting it as kind of truth and working on it to do some predictions. Like what will happen in the large time? How does the equilibrium state depend on the shape of the box? How fast is the approach to equilibrium? How smooth is the solution? What happens for if you remove the conservation of energy in the particles? What happens if you consider long-range interaction as opposed to short-range interaction? How does the shape of the interaction between two particles influence the properties of solutions of the equation, and so on?
Wow, so it's actually very, very in-depth, and you wrote a paper on this, and then you get a phone call.
Are you kidding? I wrote dozens of papers on this.
I'm sarcastic. I mean, you spent a large portion of your life on it, and then you
Yes.
get a phone call to say that you've won the Fields Medal.
Right. I did not get the Fields Medal from working just on this equation. The equation was obtained from my work on the Boltzmann equation and my work on the Vlasov equation, which is another statistical equation.
Tell me about this other equation. What is this other equation that you were working on?
It's the same as for Boltzmann, but for plasma. Gas and plasma are very different states of matter. They are both made of particles moving through all kinds, but in the gas, particles bump into each other. In the plasma, they just repel each other, but they never collide. It's long range. So the mathematical properties are very different. And my prize is obtained partly for the works on the Boltzmann equation in relation with the entropy, and in collaboration with some researchers from France and Italy, and partly for my insights on the Vlasov equation for equilibration in plasmas, which is a very different phenomenon. And this was done in collaboration with my former student, Clément Moore, my first student.
Wow, that is fantastic. So now you've done all this research on both equations. People obviously taking note because you are quite prominent in what you're doing, and you get told that you've won the Fields Medal. Now, just for the people that don't know, the Fields Medal is the equivalent of the Nobel Prize for mathematics, but
there is with certain conditions. Yes,
it's only given to people under the age of 40.
That's right.
So that means it's a very small group of people that could possibly even win that, because some of your best work only comes between the ages of, let's say, 30 and 50, and they're nailing it to under 40. That's quite a prestigious award to receive.
It's an enormous constraint, indeed. It's an enormous constraint. So, what we can say first, I like that you said taking note, because it's the basis of the life of a mathematician is to think and write the papers and talk, and lecture, and listen to others. We literally spend our life doing this. During my most active years in Lyon, I used to attend maybe 4 lectures a week, something like of further mathematicians. I have taken maybe that of notes during these years about all the talks that I was listening to. And traveling, it's common for mathematicians to travel in dozens of countries to explain, and discuss. And yes, after all this process, are selected some people for the Fields Medal, only people below 40 years old. And it's a long process in which the various subfields of mathematics should be represented. Of course, you cannot each time do justice to all of them, but you try that they are not all in algebra, for instance.
Uh-huh.
And this prize is not only specialty, is not only the fact that it's awarded to people below 40, but also the fact that it's awarded every 4 years only.
That's right.
Every
I mean,
4
that's.
years
You take your constraints and you really, like, you know, when you talk about those graphs where they start chopping off all the possibilities, I mean, then you're really talking about only a handful of people that are worth paying attention to.
It's still, there is some big competition, let's say. There is some big competition, but from the start, let's say each subfield of mathematics identifies maybe half a dozen people in this subfield that they think worth of it. And then they are compared with people from other fields. It's a tricky process.
But now, were you aiming for the Fields Medal? Is it something that you always think, I'm an actor, I'm hoping I'm going to one day win the Academy Awards? Or are you just doing your own thing and then people say, you know, that's very, very good what you're doing, and someone's been paying attention, and maybe they might be interested in giving you an award? I mean, how did it come about for you?
First, the prize is attributed by the community, in front of the community, not by an academy, and the jury is secret up to the end when it's announced. So you have no idea who you're trying to influence.
Okay.
So if you want to get Fields Medal, no politics is possible. Only thing is to do some good work. The second remark is that everybody knows, let's say, in the field, that you never talk openly about it, and you never aim explicitly at it. It would be contrary to the ethics. Of course, you may have it in the back of your mind, and it may be for you really something that you become obsessed with, but you will keep it secret, and you will never even think of it explicitly.
But I mean, for you, I mean, obviously, knowing that it was out there, that wasn't your motivation for the work that you were doing. You were doing what you were doing because that's what you loved doing. The fact that there was this incentive and the acknowledgement is a bonus. Is that correct?
I was aware of the fact that the Fields Medal was a possibility. However, I did not change my research projects for that, and I did not change my schedule for that. But I was aware that it was possibly hanging there, and it was putting a big pressure. I was giving myself, just before I got the phone call, I was estimating my chance around 40%, which I think was a rather good estimate in retrospect. You know, there is always some element of luck, depends what the jury likes, and so on. But I think my estimate was quite correct.
I'm sure there's an equation that could define your chances on that one. And now you go and win this prize, and now all of a sudden you become the poster boy for mathematics. And I'm almost certain that once you get this award, everyone now looks to you and says, well, because you've won the Fields Medal, you must now be an expert on everything to do with maths. And we want you to go to every single speaking engagement. We want you to meet every single person. And I mean, I know how it works with people that we interview, and you know, whether it be an astronaut, whatever it is, and you've done something special, you then become the flavor of the month, and you have to go everywhere.
Yes, and you have to be everywhere. That's the tricky part. It's not just like writing. You have to go there, and transport become really a part of your life.
I can imagine.
You know, I was last summer, for instance, I was in Vietnam. I was in Thailand. These visits were arranged with the embassies and with the people helping and so on. And I don't know, maybe in 2 weeks I took 10 planes, something like this.
But now you have a young family, so it must be quite difficult to be away from home for I mean, when you first won the award, that was only in in 2009. Is that right? Which means, so then your kids were probably young toddlers, 5, 6, 7 years old at the time.
No. I had my kids at age 27, my first kid. So he was already 10 years old.
10 years old. Okay, so I mean, to be the flavor of the month and to be everywhere, obviously the kids are at home going, you know, wow, when do we ever get to see Dad? Was it a tough situation like that?
No, I really think they don't care.
Oh, good, he's going! Yay!
At some point, it was a bit embarrassing to them, maybe, for the public attention, because they don't like this. But they don't watch TV. They don't have radio. My kids. So often, my family is the last informed about my appearance.
So you're not really a tech. I mean, your kids are not technology people at home. They're not sitting on iPads all day long. They're more like reading that type of thing.
No, they do spend quite some time with their computer, but they are not hooked on the information and so on.
Games and that sort of thing. Okay, so now you've won this award. Did it change the work that you were doing, because now all of a sudden more people wanted to collaborate and that type of thing, or did you offered better job opportunities because of it?
It's more than changing. The truth is, it stopped. But it was even more tricky for me, because not only did I do this job that you described, but also I am director of a research institute since 2009, with all the problems of a research institute that wants to increase and get millions in millions in this and that project. And also I am president of association, also using the opportunity. And all this consumes enormous amounts of time. And I wrote the books. So this also was a difference. I wrote several books which to describe what is the project, what it is like, the life of mathematician, among other things.
And your recent one, the theorem, the
Birth of a theorem, yes.
That was a bestseller in the UK, like all over Europe. Is that correct?
It worked very well, with some differences. It sold more than 100,000 copies, all in all, and so France, of course, was the best success. Then it was the UK and Germany. It worked very well in Germany, but it was a big hit in the UK.
Mm-hmm. And now, I mean, you're an author. You're a scientist, you're a mathematician, you're a Fields Medal winner, you're a TED speaker, you've done a couple of TEDx talks as well.
Right.
So
I'm
where do you find time to do what?
I will speak at the next Global TED in Vancouver.
That is fantastic. So now when do you find time to do all the other things that originally were making you filled with passion?
The answer is I don't find the time. It may be a sad truth, but I still am very much aware of what is happening. As an editor, I discuss with the people, I see it. I still teach, because even when I'm not compelled to, because I think of my identity as a teacher first, but there's hardly any time for me left to do research, almost nothing. To do research again, I would have to give up either writing books or developing my institute, or developing the other projects, associative projects, and so on. And all of them would be a heartache. One thing I learned in research is when you have an opportunity to do something and work on something, you have to grab it now and not say, hold on, I will do this a little bit because I want to also spare more time for this and that. If you really want to do something, you have to get involved in it.
Aha. Now, one thing that I've always found fascinating is that when you go back in time and you speak to scientists and you speak to Einstein and all of them, what people didn't really know is that those scientists, as much as they were competing in various fields, they actually had a camaraderie where they would get together and discuss their research and listen to each other and critique each other. Today, I find scientists are so protective over their intellectual property because if someone else has your ideas, you lose research funding. If someone else gets your idea, the next big corporate investment goes to another university and not yours. So people are now becoming quite protective over their content. Do you find that is happening in the maths field as well?
Math is certainly not as much suffering from this as other fields, because it remains a small community compared to other fields, and because we have a lot of culture, of behavior, of what to do. Think that, for instance,
I like that.
Yes, you know, mathematicians spend their life thinking about what is the way that things should be, and it has implications also in their social activity in the Society of Mathematicians. So, for instance, it happened to me that I discussed and exposed freely works which I had done, research, 2 years or even 3 years before publication, and I never had any serious problem of dispute. It is true that in the old days things were more relaxed. Everything was more relaxed. There were less people, less money for the big projects, less rankings, and less publications. We are publishing too much, that's for sure. And in mathematics, yes, but in other sciences, even much more.
Sure, and now with obviously the internet, you have access to so much, and that could lend to people claiming responsibility for some parts of research that other people have done, because why reinvent the bagel? You know, if it's already there, you can take advantage of it. Do you find that because of the internet and the sharing capability, that there are advantages where people can collaborate and do so effectively from different countries? So that's the pro. But the con is that if you make your stuff available online, people can just use that and build on it from there.
The collaboration, long distance, yes, it's a reality, and most of my best work was done through internet collaboration on various continents. But the drawbacks exist. The main drawback of the internet is not the one that you for fundamental science. The risk of stolen intellectual property. The main drawback is the fact that it spreads ideas too fast. It's always good when people have time to develop their own ideas different from the mainstream. Everybody thinks the same, lose opportunity for original work, and there are many examples of in the history of mathematics of big discoveries which were made independently in various places without communication, with very different approaches, and that was much richer than it had been all the same approach. The same way as it would be a disaster if all cultures in the world would think the same, thanks to too much internet communication.
But now, as a mathematician, people might critique you and say that you think in logical steps, you don't really think outside of the box. What is your comment about that?
It's as weird as to say that if if you are a sculptor,
Mm-hmm.
You are not creative because your statue obeys the laws of physics.
Okay. So you are gladly, I'm hoping that you are saying that mathematicians are obviously creative and have to think outside the box, especially when it comes to finding innovative solutions to solving certain theorems and problems.
I will tell you, when we are publishing, when we are editors of a book, let's say, and we send the paper, we send it for evaluation. We ask the expert in charge of evaluation. We ask, does it contain new ideas? Is it sufficiently innovative, and does it have enough important applications? So we judge the applications and the innovativity, and these are the two criteria. And if there are no ideas in the paper, it will not be published.
So that's good. So you are obviously encouraging innovation. But now let's take it back one step. And when we think of mathematics, we teach a few thousand students a week, and we work with the younger grades, and for us to inspire people to get involved in mathematical thinking is very easy. Some people say, oh, your job must be so tough, selling a product that no one really wants. And I'm thinking, on the contrary, I find my job very easy, because it's very easy to promote the excitement of mathematics when you show the different aspects. When we go to a school and we ask people, do you like mathematics? They say no. And then I ask them, do you like music? And they say yes. And then I say, you are a hypocrite. Why? Because if you like music, but you don't like opera, that doesn't mean that you stop liking music. You just don't like that part of music.
Yes.
So when people think of mathematics, they think of one aspect, the kind of problems that they do at school. Maybe it's algebra or geometry or trigonometry, whatever it may be, and they don't like maths because of that particular section. But there are so many other fields within mathematics, whether it be combinatorics and string theory and things that they have never been exposed to, so it's not really fair for them to judge the whole of maths based on one particular section. I mean, if you are now the so-called ambassador for mathematics, why do you think the world is not such a big fan? Do you think it's because it's too much hard work? Do you think maybe it's not being taught in an exciting way? What is your
answers, but certainly no miracle solution. But you know, one problem first is that what you are taught before, what you are taught maybe some problems of computing and applying rules, that's boring. And it can be about finding new reasoning, and that can be fascinating. But let's use this music analogy that you are giving. Imagine that all of your music life is just about reading the what do you call it? Reading the notes, reading the music, and knowing your scales, and knowing by heart which is the fifth of what. You think this is funny?
No, that's not exciting at all, and that would switch a lot of people off.
But that's essentially what we are doing when we teach calculus to the young kids. We are teaching them only the rules, the mechanical rules for the construction. And of course, it's not exciting. In music, it becomes exciting when you can read some beautiful work and hear how beautiful it is, or when you can compose, or when you can improvise some work and so on. But definitely not by studying the mechanics of it. Or to take another example, teaching mathematics, basic calculus rules, is a bit like teaching, like in art class, teaching people, spending your time teaching people how to use an automatic paintbrush, you know, that will spread the painting and so on. It's a bit boring.
So how do we, as ambassadors of mathematics, how do we get to convince teachers, schools, districts, that more context needs to be put into the curriculum? I mean, is that something that happens in France as well? That schools come to the university and say, how do we inject more context into the environment?
More context, but also more surprise. For some, it's more. For some, it's more games. For some, it's there is no magic rule. There is no magic rule. All you can do is do experiments. The most important is that the teacher be aware of the possibilities and can experiment for oneself.
So that then, obviously, the teacher's limits in terms of content knowledge would be a problem for the kids. If your teacher only has a certain constraint or certain limit of their knowledge of mathematics or thinking outside the box, they can't generate or excite the kids further or stimulate them further if their limits are only in one section.
That's right. But it's the first rule, you know. If the teachers don't like it, sincerely, they cannot get the kids to like it.
Yeah. Well, that's the biggest problem in primary school level, that teachers who teach primary school teach a range of subjects. So they're not math specialists, and therefore, if they don't like maths, it's only one portion of what they have to teach, and they just get through it because they're obliged to. But, you know, when you come in as a math specialist and you get excited about it and you encourage people to you know, for example, the kinds of things that we would do is, you know, we would ask, could Noah have taken all the animals on the ark? And of course, people say, well, how do we know? Well, how big was this ark? And we would go look at the sources and say, you know, it was so many cubits long and wide, and let's go onto a field and mark it out. And do you think you could get 2 of every animal onto a vessel this size?
The final problem.
You get to challenge the norms and the standards. It might be, for example, can you crack this? You know, when your parents put a 4-digit code on the TV to stop you from watching certain programs.
Yes.
How many combinations would you need to attempt to actually crack that code? So, you know, it's about looking at real-life examples. And right now in Cape Town, we are celebrating the African Week of Code. And we are firm believers that, you know, in terms of doing coding, that does develop your problem-solving skills. How do you get your program to behave in a certain way?
Yes.
Actually, you're seeing that in your field as well. A lot of coding and a lot of computer science.
Context, computer science. Also, the problem is how to program, how to write a computer program. Or the rest doesn't deserve to be taught at school. And this is a big question, how to motivate and put in context. Yes, above all, it's an interaction, teacher-student, which is important.
Yeah. I actually think that it also boils down to role models. You know, it's very important to have someone that you can look up to. And let's say, for example, you go to a school and you speak to high school students. You're not going to sit there and extrapolate on the Boltzmann equation. You're going to talk about the exciting aspects of mathematics, because at the end of the day, you want to encourage people and not turn them away.
Most of the time when I do public lectures, I don't even talk about the Boltzmann equation. I talk about the process of innovative ideas, or I talk about some of the big innovations in the science of the past and now, or I talk about the artistic value in science and mathematics. It can be all this.
Wow. I mean, I just had a demonstration about 5 minutes before.
I have a talk which I do regularly in front of school kids about mathematics of the bat that flies.
Yeah. Wow.
What mathematics is used, why, for instance, at the end of the lecture, they understand why the bat has to fight against the uncertainty principle of Heisenberg every day to get a living.
So you see, now that to me is the way a subject should be introduced. You know, when I think of mathematics and someone says to me, you know, how do you teach, for example, algebra? I don't start off even mentioning algebra, because the minute you start mentioning big words, people switch off and they go, this sounds too complicated. Why are they bringing in all these extra letters? But what you do is you bring in a scenario and you talk about something that they can relate to, and then all of a sudden, so for example, if I was doing, let's choose gradients, and we're looking at graphs, you know, I would ask the first question. We have a guest speaker coming to the school, and they happen to be in a wheelchair, and we need to get them onto the stage. How are we going to do it? And of course, everyone says, build a ramp. Sure, we can build a ramp, and then they can draw the designs, and then you ask, do you think that anyone could actually travel up that ramp? Is it not too steep? Yes, it is. So what are the main factors involved in that ramp? Obviously, the height and the length. And they start to experiment with concepts that come from things they can relate to. So I think it's very important to have role models who can bring things that they can relate to. And in particular, you were talking about art, and I just had a guy in my office literally 5 minutes before we started speaking, and he was showing me how this artist has taken computer and he translates sound into images. And he's also got movement. So he had, for example, people who run around, and you can actually see the blur of the person, and you can pause it and then 3D print it.
Oh,
so
yes.
You can physically have that motion in an actual 3D printed design, which I think is absolutely fascinating. And they're busy talking about getting it to be printed on the International Space Station. So that's going to be another person that I'm quite interested to interview. But now, talking about art, I noticed that you are quite a big fan of music. You are also a big fan of fashion. And I noticed that you don't dress the way a mathematician normally dresses. What is the story behind this?
It's a legacy from my years at École Normale Supérieure, and the time where I had to find my identity. And somehow I discovered I needed to find my own way of dressing. So I was 20 years old, and I started to experiment about various possible looks until I found one that I could say, that's me. So it's always three-piece suit with a
watch
and a cravat or a scot or bow tie. And the spider came about 12 years ago. The hair has been long since 20 years, medium long. The beard is innovation. It came out last summer.
I was going to say, this is recent, because from your TED Talks, you certainly didn't have a beard. So now you've become hipster, oldster.
Hipster.
Yeah, there we I like that. I mean, it's, you know what, I think it's important to obviously pinpoint your own identity, but that makes you unique then. So when people think of Cedric Villani, they think of the guy that dresses like he's back in the 19th century or the 18th century, whichever century it comes from. Do you struggle to get clothing? Or is vintage back in fashion again?
Actually, I accepted only once to be in a fashion magazine, but I had several requests to be in fashion magazines or fashion books. And because I always say it's each of us should find their own style. At the beginning, I was looking for my clothes as second-hand costumes from the old days and so on. I had some pretty original ones, very interesting ones with this. But nowadays, I get them. I get them with tailors, and this, for instance, this one is a Hackett costume. I like this brand very much.
That is fantastic.
This one was made for me by a tailor, The spider also, this one was made for me by a Tuareg artist from Niger.
Well, let me get a photograph. You want to just lean forward again? So I'm going to take a photograph with the screen. There we go. Got it. Excellent.
Yes, so it was designed in Niamey.
Uh-huh. So you've got a group of people who are now helping you to manage your brand, because at the end of the day, you are a brand. You know, you are a public speaker, you are a prominent person, and a fashionable person. So you have to manage that brand.
Yes, there is a group of person which is essentially my wife and a couple of female friends. You always should ask girls to give you advice about how to dress.
And what do your kids have to say about it? Because, I mean, you know, they're teenagers now, so they're at that stage where sometimes it's cool, sometimes not so cool.
Yes, they would say like, "Oh, Daddy, why don't you get yourself a pullover for today?"
You'll notice that in the parcel I sent you, I didn't send you a T-shirt because I didn't think it would fit in with your style.
Well,
But
sometimes, you know, for hiking and so on, I can bike with this suit, but I can definitely not cross the forest with it.
okay. And if you go to the beach, do you wear costumes that come down to your ankles and you know the old-fashioned stripy type costumes?
No,
Not yet. You haven't got there yet. You haven't found a tailor.
I haven't thought about it yet.
Oh.
I haven't thought about it yet.
See, I'm planting ideas in your mind.
We need to get some margin to progress all your life.
I think it's fantastic that you haven't, you know, stuck with mediocrity. Mediocrity. You've actually chosen a niche, something that is very Cedric, and no one else is like that. And I think that that's important, as I said, for brand awareness, especially if you are from a commercial point of view, if you're doing speaking engagements and that type of thing. When people know that you dress differently, that already piques their interest, and it's a great marketing tool as well. But now, what are your plans? Like, if I said, you know, your next 5 years, I mean, right now, your equation couldn't even determine the entropy of how things are going with all your projects and things. What's going to happen in the next 5 years? What would you like to see happening?
First of all, as director of institute, I am engaged in big-scale projects, and I have seen that it is true what they say when you want to do a big administrative project, change things. It's something like 10 years. 10 years of work. Now I've already been there for 6 years, and I'm starting to have the means to do things. In the next 4 years, we have to expand the institutes, expand our budget, expand our staff, and so on. Everything is being prepared. It's a big amount of meetings. It involves hundreds of people because various institutions donating, various institutions to help, and so on and so forth. So meeting people, and it's years and years and years. In 5 years is just not enough to put your mark on an institution. That's what I learned.
And so you're definitely there for a while.
Yes, you need to be there for a while. I think at least 7 years, which is interesting. Also, we can see, by the way, that at level of politicians, when they have mandates of 3 years, 4 years, 5 years, they can't manage to do anything. And so this is the big thing. I am also president of an association. It's called Mosaic, like music, but like mosaic. And it was founded by an extraordinary musician and engineer. And I am president of this association now, which devises new technological type instruments that everybody can play.
So you're a maker as well.
My association is a maker. It is true.
I'm very excited about that.
Do I have a picture around here? Not so sure, but you see here, for instance, the photograph here. Here
Yep.
I am standing in front of one of these music instruments
Okay.
in which there are some ropes that you can stretch, and this will change the sound.
Now, I wasn't aware that you were part of the maker movement. Have you been hiding that away? Because that's the most fascinating thing. I mean, I've got some very good friends in the maker movement who are involved with maker fairs.
Because we have to rediscover our hands now. We've been going abstract and digital for so long. Now we have to rediscover the hands.
Well, in the old days, you used to solve everything with a pencil and a piece of paper. Now you've got all these special tools to help you do all the calculations. I mean, I find that in some of the schools, in some of the poorer areas where we teach, some of these kids are in the 12th grade and cannot even do the 9 times table without pulling out a calculator. They are so dependent on the technology.
That's kind of right. That's kind of right. It's also one of the stakes today that we don't forget about the making, and the job of mathematician has been repeatedly in the last few years ranked as one of the most important, or maybe the #1 job to play a role in the future because of the importance of the algorithms and abstract recipes. But it's also very important to have people who have a culture of skill of making things, doing things, which are concrete objects. This is otherwise. This is one of the loss of the skills of making is one of the reasons why the West is losing ground to Asia.
Correct. And I mean, I think that innovation starts off when you tinker, when you actually play with things. Young kids in schools, when they first start off, they do a lot of painting and they experience, hands-on making and building in clay. And then they get to high school and the focus is so much on academics that they push all the creative stuff away. And a lot of the kids lose out on that creativity aspect. And then when they get to university, sometimes they rediscover it and sometimes they don't. But I'm very excited about the wave of the maker movement that is now taking over the world and getting kids to take things apart and to break and design. And I mean, we're involved with so many fun things that are involved in the making. And I'm very excited to hear that you're involved with instruments.
Let me show you something.
You can show us. This is what we're here for.
This is my last literary project.
Okay.
You see, maybe you recognize this guy.
It looks like a Rube Goldberg machine that solves codes.
Kind of. And this is Alan Turing. I
was going to say, it looked like a Turing machine.
Absolutely.
Where he did it from the movie.
Yes, I hated the movie, by the way.
Why?
Because it's so much distorted from the truth. It's okay if you don't know the story, but the level of distortion which they applied is really unacceptable in my view. And
so you are definitely a purist when it comes to at least get the basic knowledge out there. Don't Hollywoodize
knowledge
the movie.
Is not there. To quote just a few examples, the fact that Turing does not point out the traitor when he is aware that there is one, and when Turing seems to be, giving in to blackmail, accusing him of higher treason. Just simply, he would never have done this. Fact that the way the love story is romanced is just unimaginable. The girl was a pure nerd and nothing like what she's played on screen. She was an extraordinary person, but definitely not glamour type. The contribution of the collaborators of Turing is grossly underrepresented, and some of the important ideas behind the bomb were due to the collaborators of Turing. Turing got out of the project before the end of the war. It's impossible to put it up to the end as it is pictured. The machine, the artificial intelligence, the computers were not an outgrowth of the decoding machine. It was in some sense closer to the abstract papers of Turing from before the time that he was in war. These are some of the examples. Plus, they did not to mention that they forget to say that the whole Bletchley Park project, the whole project of decoding, would have gone nowhere if it had not been first for the Polish mathematicians for their first contributions. Without the Polish mathematicians, possibly the outcome of the war would have been different, or at least history would have been different. It would never have stopped in 1935. So this is really a lot of problems.
I can imagine, and frustrating for you to watch that and then know all this background information and think to yourself, but you did enjoy John Nash's movie, A Beautiful Mind?
I did not like it. I think it was less serious. I did not like it either because it was focus. I think it was giving so much importance to the mental problems of Nash and not enough to his big science achievement from before. And that for me was a truly inspiring story of Nash, the achievements, much more than the illness. I knew Nash personally. I even was his last chairman just a few days before his death. And for me, he's an extremely inspiring character, and I think he deserved much better. Even though
what did he think of the movie?
Sorry?
What did he think of the movie?
Oh, he hated it.
Who could possibly play you and get your life? I mean, who would play your role in your movie?
Actually, John hated both the book and the movie, but I think that the book was good. I think the book was good, even if the movie was not so good. But it's normal to indeed be embarrassed by the way things are represented, especially a lot of details that he did not want to be public. But still, better could have been done. And after all, the movie was a significant source of income for Nash, who lived a very difficult life at the end. No regular source of money and so on.
Why is it that famous artists sometimes the famous mathematicians, the end doesn't go so well? What is the story with that? There seems to be a pattern.
It's not only for the mathematicians, I guess, but artists, yes. Think of the miserable life of Rimbaud in his last years, because maybe what they best know how to do is not so easy to convert into a job. In this book, you see, I consider 4 of these people who are, I call them rêveurs lunaires, moonshine dreamers. But they also were a bit weird or thinking differently, playing a very important role in the war, or at least some important hopes. One is Heisenberg, the other is Turing, third one is Leo Szilard, and fourth is Hugh Dowding. Hugh Dowding was the very original general in charge of the Battle of Britain, that when the United Kingdom resisted Nazi invasion. And Leo Szilard was the extremely inventive physicist who started the Manhattan Project in the making of the atomic bomb. And he also had such a difficult life and never and for a long time, no permanent position, and so on. Well, but it's when you go deep into their personalities, you see that there are some very different ways to consider reality. Turing did not like reality, was never interested in politics or in anything related to the economic outside world, let's say, or the political world. While Szilard, on the contrary, was extremely into politics and for fighting for peace and going lobbying governments and so on. So very original personalities can have very different relations to the outside world and society.
That the great intellect, which was symmetrical to the great personalities, created these unique individuals.
Yes, they are all unique. It's funny to see some features coming in and there. For instance, while working on the project, I discovered from their biographies that both Turing and Szilard were exceptionally bad writers. Their handwriting was illegible. That they.
So is half the medical profession.
Sorry?
So is half the medical profession, but that's okay.
Yes. And that both of them had their whole career influenced by a book that they read at age 10.
Wow.
And determined all their life in some sense.
That is insane that they had that coincidence.
Yes. Yes. There's something deep there. That's a question we could ask.
So if, for example, we find those points on our life graph that become turning points, the asymptote, where all of a sudden you read that book and then your whole life shifts or changes, it would be lovely if you could write an equation to find all those turning points, that we could influence the whole world and make them fall in love with numbers and thinking and problem solving and making and music and all the other things that we want to promote. Now, it looks like our time is coming to an end, but I just wanted to say thank you very, very much. I know that Sebastian joined us for the whole talk, and we had Govinda from Nepal who was with us for portions of the talk. And I know that it is your birthday, and it is now probably the same time as us, so you need to get out there and go and party. I'm sure you're going to find a nice restaurant with your lovely outfit to impress everyone with it. French champagne for everyone.
There is no lots of fine restaurants here in Paris.
Well, thank you. Merci beaucoup. And I will make sure that I email you the photographs of the screenshots that I took.
Super.
And I will also, in fact, you have to smile for the camera.
Yeah.
So let's have a look if you're smiling. There we go. Got it. And I will make sure that the video links as well. But thank you so much for sharing your passion and your joy and excitement for mathematics. And we'll be watching closely to see if there's another award that comes after the Fields Medal that they can possibly even throw at you again. You never know.
Who knows?
Back of the mind, okay?
Bye-bye.
Thank you, merci. Bye-bye.